All right, let's talk about something that you use literally every single second you're online, but probably never even think about. We're diving into DNS, the domain name system. It's this silent, invisible engine that is absolutely essential to the internet. Without it, the web as we know it would just, well, it wouldn't work.
I mean, really think about it for a second. You type in a website, you hit enter, and like magic, a page loads. But what in the world is happening in that tiny, imperceptible gap between your click and the content appearing on your screen? That's the secret journey we're about to uncover.
And this right here is the heart of the problem that DNS was born to solve. We, as humans, we think in words, in names, right? Google.com, easy to remember. But computers, they don't care about names. They speak the language of numbers, specifically IP addresses, these long strings of digits you see on the right. There's a huge disconnect.
Just try to imagine that for a second. What if, to check your social media, you had to type 157.240.22.35? It would be total chaos. You'd need a physical notebook next to your computer just to browse the web. No way, right? It's completely impossible to scale.
And this is where our hero, DNS, swoops in to save the day. The absolute best way to think about it is right here. It's the phone book of the internet. Its one critical job is to take the human-friendly name you give it and find the computer-friendly number that it corresponds to. It's the ultimate translator.
So, how does this giant global phone book actually work its magic? Well, let's go on a little adventure. We're going to follow a single request on what I like to call the Great IP Address Hunt, tracking it all the way from your keyboard to the final answer.
Okay, so our quest kicks off with something you do a million times a day. You type www.example.com into your browser, you hit enter, and now your browser has a mission. Find the IP address for this domain or you're not going anywhere.
Now, this isn't a simple one-step lookup. It's a whole chain of command. First, your browser is a bit lazy, so it checks its own memory, its cache, to see if it already knows the address. If it comes up empty, it asks for help from something called a recursive resolver. Think of this as a detective. This detective starts at the very top, asking a root server, which is like the master index of the entire internet. The root server doesn't know the final answer, but it points the detective in the right direction, to the TLD server, in this case, the one that handles all the .com addresses. That server then points to the final source of truth, the authoritative server for example.com. This server holds the official record, and it finally gives our detective the IP address, which is then passed all the way back to your browser.
And boom, there it is, the treasure at the end of the hunt. The IP address is found, the quest is complete, and your browser can finally connect and load the page. And get this, that whole chain of events just happened in less time than it took you to blink. It's incredible.
So, just to lock that in, here's a quick rundown of our cast of characters. You've got the cache for speed, the resolver acting as our detective, the root server as the master index, the TLD server as the specialist for things like .com or .org, and finally, the authoritative server, which has the final correct answer.
But wait, there's more. This phone book is way more sophisticated than the one you might have by your landline. It doesn't just store one type of information. Let's decode the different kinds of entries, or records, you can find inside. You see, a simple name-to-number translation isn't enough to run the modern internet. We need to handle web traffic, deliver email to the right place, verify domain ownership. The list goes on. So DNS uses different types of records for all these different jobs. First up, we have the A record. The A stands for address, and this is the bread and butter of DNS. It's the most common type, and it does exactly what we've been talking about. It points a domain name straight to an IP address. This is your main website listing. Next up is the CNAME, or canonical name. You should think of this one as a nickname or a shortcut. Instead of pointing to a number, it just points to another name. This is super useful for pointing the www version of a site to the main domain, so you don't have to manage two separate records pointing to the same place. Okay, now this one is huge. The MX record, or mail exchange record. This is basically the post office for the internet. When you send an email, the MX record tells the internet's mail carriers exactly which server is supposed to receive mail for that domain. Without this, email as we know it just wouldn't work, period. And the list keeps going. There's the AA record, or Quad A, which is just like an A record but for the newer, longer IPv6 addresses. TXT records let you store plain text, which is crucial for security and proving you own a domain.
And the NS record officially declares which server is the authoritative one we talked about earlier.
So, this system is a work of genius, right? But it's not foolproof, because it's a massive distributed system that spans the entire globe. It faces some very real-world challenges. Let's talk about the dangers and delays. One of the most common headaches is something called propagation delay. So you change your website's IP address. You'd think that would be instant for everyone, right? Yup. Because servers all over the world keep copies, those caches we mentioned, it takes time for that update to ripple out. It can sometimes take up to 48 hours for the whole world to get the memo. And of course, because DNS is so fundamental to how we navigate the web, it is a massive target for bad guys, which leads to a really scary question. What happens if the phone book lies to you? What if an attacker manages to give your browser the wrong number on purpose?
Well, that attack is called DNS spoofing, and it's incredibly dangerous. Here's how it works. You think you're going to your bank.com, but an attacker intercepts your request and sends back a fake IP address, one that leads to a malicious website that looks exactly like your bank. You log in, and just like that, they have your password. Thankfully, the internet's architects thought of this. There's a defense called DNSSEC, which stands for DNS Security Extensions. The easiest way to think about it is like a digital tamper-proof seal on the DNS records. It uses cryptographic signatures to let your resolver verify that the answer it got is authentic and came from the real source, not an imposter. It's a layer of trust. So let's just wrap this all up. Why does DNS matter so much? Because it's the invisible workhorse that makes the internet usable for humans. It translates names we can remember into numbers computers can use. It makes sure your email gets to the right place. It's what makes the web navigable. And it even has security built in to help keep us safe, all while working silently in milliseconds with every single thing you do online. So I'll leave you with this final thought. DNS is a truly brilliant system, but at its very core, it's built on trust. Trust that the IP address you get back is the correct one. In a world that is becoming more and more digital, you have to ask, what happens if that fundamental trust gets broken on a massive scale? It's definitely something worth thinking about.